Hi, my name is Cristoff. Welcome to my talk on how to establish and maximize the value of DevOps-style deployed SUSE Rancher. The agenda, first one is introduction, next one is status quo, challenge, and last not least, the solution, what is URI? As already said, my name is Cristoff. I'm working as a senior cloud architect for full stacks. I have like 15 years experience in the industry. Started working with Linux when it was casual, installing it from a CD. The who we are and why we're here today. In brief, Fullstacks is a full spectrum digital service provider with strong technology focus on DevOps, cloud native, Kubernetes, infrastructure as code, and full stacks observability. We are SUSE Platinum partner and double gold partner and focused on Germany, Austria, and Switzerland region. We used SUSE Rancher since its first release, that was in like early 2015. Our mission is to create value with the right technology for our customer, or in other words, we are the DevOps travel guide for businesses. Status quo, DevOps at enterprise. So where we currently are. Kubernetes is the de facto standard for how software is deployed and operated today, no matter where, in the edge, in the core, or in the cloud. Kubernetes is a kind of an operating system for cloud and legacy computing. So it's kind of a standard, just as the IP protocol is a standard for the internet. Almost everyone deals with it and often invests a lot of time in it. Do you use the internet? Sure, it's commodity. Now we bridge the gap from the IP standard to Kubernetes. Do you care about IP addresses? Probably not. So why companies care so much about Kubernetes and what do they really need? That's where we come to our challenge, DevOps at enterprise. Everyone knows best where the shoe pinches him. Really? Kubernetes is a kind of a gigantic open source puzzle with 10k pieces and no single solution. And companies need a solution to this puzzle, and one piece of the puzzle is Kubernetes. In reality, companies need a DevOps platform, so this platform must be part of a modern IT architecture that optimally supports the business. The components in it must become commodity, as normal as the air we breathe. That's where we come to our solution, or what is URI? It's one part of our solution for the 10k pieces puzzle. What is URI? So what does URI mean? URI stands for Universal Rancher Installer. And the idea behind the Universal Rancher Installer was the complete automation of the entire SUSE Rancher ecosystem with our infrastructure as code approach. Rancher in every manifestation, in every environment, is code, repeatable, individualizable, and flexible. Everything is an artifact and everything is in pipelines. So what's the plan behind URI? The plan was to dig a hole from legacy IT to a modern DevOps-style organization. In most of the cases, we are going along the following plan. So first part is to create a VM template with Packer. On a newly installed VM, from the template we create a harbor registry. With other VMs from the same template, we create an RKE cluster with Terraform. On the RKE cluster, we install and configure SUSE Rancher with Terraform and Helm. Now with the installed Rancher, we are able to create infrastructure as code templates for Rancher clusters. And with this ready-to-use Rancher, we are able to create infrastructure as code templates for Rancher clusters. With these templates, our customer is able to enjoy hassle-free Kubernetes and is able to concentrate on more important stuff. So why do we need automation for Kubernetes clusters? With these templates, we enable our customers to build and maintain Kubernetes clusters, where and whenever they need them, as big or small they need them. These clusters can be created manually or from pipelines. The creation of clusters can be included into build process, and this even on premises, like in the cloud. Clusters can not only be created, but also removed effortlessly and without leaving any traces. Clusters created from our infrastructure as code templates do have all standards applied from the beginning. For example, persistent volume providers registered with a CI/CD tool of choice, logging to any company log sync, integrated with monitoring tools, or with container security tools like Neuvector. All of this is done in infrastructure as code, versioned and auditable. What you can see here is the solution to our 10k pieces puzzle. It's a drawing of all the components we take care of with our infrastructure as code approach. Now I'm already done with my slides and like to invite you to a small demonstration. So this is where everything starts. We here have our code in Visual Studio Code. In the end, it doesn't matter. We just need a text editor. We already put the code in there. So we have two folders, one for Rancher and one for downstream cluster. Of course, we can, as already said, not only have one downstream cluster, we can have as many as we want. If we open the folder, we have everything in here, like our Terraform modules. We have our Rancher deployment itself. The Rancher deployment is divided into two parts. So we have Rancher infrastructure, which means in the end our VMs and installing the RKE cluster on them. And in the second part, we do have the Rancher installation itself, which is dealing with Helm charts and Kubernetes. If we have a look in the Rancher folder, we do have several files here. One is for our GitLab CI pipeline. One is the creation of the cluster itself. So we created a Terraform module, which is just called here. It's called cluster. It's loaded from local file because it was already packaged. It has a dependency, so it's waiting for our nodes. You will see this later. And we also pass created SSH private key to the module and a possibly existing private registry. In the nodes.tf, we create, as already said, we create a SSH private key, which we will need to log into the VMs, even with the Terraform provider, and we create our VMs itself. So for the VMs, again, we have a module created for Terraform. This particular deployment will now create a module in a vSphere, so in a vCenter environment. The module call itself is configured from a variable. We can have a look at this one later, but so you can see here's a for each. And so the module is just called as often as there are VMs in our variable. We pass all the information like vSphere data center, data store, whatnot. And with this one, Terraform will create our VMs. As already said, all the informations we need to deploy our VM, we do have in our variables file. So we have here one array or one list. It's called nodes. And in theory, we could add as many nodes as we want. For this example deployment, we don't only have one node because it's a bit faster in the end. So if we have node name, our node will get the roles etcd, control plane, and worker. We use a node time SUSE/15. It gets 4 CPUs, 8 GB of RAM, one disk with 60 GB, which should be sufficient for our example deployment here. We configure the network information and all information we need for our vCenter. The vCenter credentials, of course, are not in this file. They will be added from the pipeline. So in this particular Terraform workspace, we created our VMs. In the other workspace, which is called Rancher install, we will install Rancher by using a Helm chart, and also dependent on the configuration, we install Cert Manager and create a self-signed certificate, or we could also upload certificates from the customer and whatnot. Everything is possible here. So again, we're calling modules. So we created Terraform modules for everything. That one is for Rancher. We pass informations to it, like the URL the Rancher will have, the version of Rancher we deploy, source of ingress TLS, that's what I already said, so self-signed or customer provided certificate. Then we could also choose an image tag. So if we have like 263-patch1 or so, that would be possible here. And again, we can pass a private registry to the deployment. So if the customer has a private registry, we are able to pull images from there. After the Helm charts have been installed, we're calling the next module, which is called Rancher config here. After the installation of Rancher, we call our Rancher config module, which is accessing the Rancher with the bootstrap password and changing it to the value we pass him here. So the code is already uploaded to GitLab, and we're now starting our pipeline. As already said, the deployment is divided into two parts. So we have infrastructure and installation of Rancher. The pipeline starts with a Terraform init and Terraform validate of both parts. And after that, there will be manual steps. So the plan and apply of the infrastructure part and the plan and apply of the install part. You will start with the plan of the infrastructure part. As said before, the infrastructure part contains our RKE cluster and the VM where this is running on. In the Terraform plan, Terraform will just check our deployment or our code against real world. So it will see if it has to create a VM or what it has to do. So it's creating a TLS key. It's creating our RKE cluster. And it's also creating the VM where the RKE cluster will be installed on. In the end, it shows us the outputs, what the Terraform plan will produce. We do have all necessary information there. So now we start the Terraform apply, and it will just execute the plan we created before. Of course, this one is fast forwarded because the deployment takes about 10 to 15 minutes, depending on the vCenter where it is running on. But as you can see, the VM is already created. It was able to log in via SSH. Now it was creating the RKE cluster, and it's finished. And we see all the outputs again, but with real values. It also gives again the information how to connect to the VM and so on. Next step is the Terraform plan of the installation part. So it's again planning and see what it should do. It has to apply Helm charts. In this case, it's Thread Manager, the Rancher itself. It will also create the namespaces and install our Helm charts in there. After installing the Helm charts, we do some basic configurations in Rancher itself, some UI tweaks and so on. Again, we issue the Terraform apply, which is executing the Terraform plan we created in the step before. It's again fast forwarded because also this deployment takes about 7 to 10 minutes. But as you can see, it's doing everything as said before, as planned. Trying if it's able to connect to Rancher, then it was connected, and configuring stuff in Rancher. The apply is finished. Now it's outputting the URL and we're able to access it. We have a self-signed cert, so we have to acknowledge this. And now we're able to log in with the password we've put into our pipeline. The Rancher is finished. We've logged in as admin, and now it's ready to use. Having a look for the nodes. As I said, it's a single node cluster. Now that our Rancher deployment is finished, we are able to do what we really want to do. We want to have Kubernetes clusters. So we change to the other repository and issue the pipeline in there. And it's basically the same. We're having a pipeline. We're doing a Terraform init, a Terraform validate, Terraform plan, and Terraform apply. So init and validate is already finished. We're starting the Terraform plan, and we'll see again what it has to do. So it's logging into Rancher, checking if the cluster is existent or not, and do what it has to do. So we create again a VM because we are deploying to a single node, or we are creating a single node cluster and having the outputs at hand. Then we fire up the Terraform apply, and we're able to have a look what it's doing. So it's logging into Rancher, creating the cluster, and after creating cluster, it takes the node registration command and issues this command on the created VM. So the cluster is already there. It does not yet have any machine or so, because Terraform is still creating this. We have to wait a little bit for the VM to boot. Now, as you've seen, it was issuing the node command and giving us all the information we need, so the hostname and IP address of the VM. And in Rancher, we can already see that it has registered itself. The Rancher system agent is now configuring everything. And after some minutes, again, this one is fast forwarded because it takes up to 10 minutes until everything is done. But we will now see that the VM is fully provisioned and that the cluster will come active. Just a little bit. Still provisioning. Yeah, that's it. Provisioning done. The cluster is active. The registered VM is active, and our downstream cluster is ready to use. You can see the nodes registered to the cluster, and we would be able to fire up any deployment we want. That's already been it with my small demo. I hope I could show you or could give you some insights on how we work and what we do and what we try to achieve. And in the end, it was not the end, because it was just the beginning. We created the platform for your Kubernetes workloads in around about half an hour, but creating a platform is not what you want to achieve. You want to run your business on a platform, and that's what we did. So the pipelines we created, for example, they are extendable. You could put steps in between at the beginning or at the end of the pipeline and run your workloads on clusters created by this pipeline. If you still have any questions, I will be available in the chat. And the last thing, what's up to me, I want to say thank you for your time. Thank you for attending the sessions, and have a nice day. Bye-bye.